Combining transformations. So recall that we have this general equation, g of x equals a times f b x minus h plus k. And so we've already talked about what the different transformations do. So recall that f just means that that is the parent graph. So that's the notation that we use when we're talking about function notation. And g of x is going to be the transformed function. And so we want to look at the variables a, b, h, and k and what they are doing to our parent function to obtain g of x. So when you are graphing these transformations, you always want to follow the order of operations, PEMDAS. And so keep in mind that that means we would want to do horizontal transformations before vertical ones because they're inside parentheses. So you're going to be doing multiplication, division, addition, subtraction, and then you would do multiplication, division again, and addition, subtraction on the outside with the a and the k. And now, why do we follow the order of operations when we're doing this? Because think about when you are plotting points on a grid. How do you plot points? We plot points using, of course, x comma y. So you always want to do the changes in x and then followed by the changes in the y. So for the first part, we're just going to write out the different transformations. So we talked about the variable b. So that would be our first transformation because it's inside the parentheses and it's being multiplied. So remember that if our variable b is less than 0, then that is going to be a reflection across the y-axis. And if the variable b is a value that is bigger than 1 or also could be in between 0 and 1. We're going to look at stretching or compressing the graph depending on what that value is. So for this one, we are going to horizontally stretch or compress it. So of course, these are your variable b. Then we come to the next one, which is h, because that would be addition, subtraction. So what does h do to a graph? So if h is bigger than 0, remember then it's opposite thinking when you're doing your horizontal transformations. So x minus h is what we're looking at, and that moves our graph to the right. And when h is less than 0, then we would have something such as x plus h, and that moves our graph to the left. So these right here are all the change in x. So remember that triangle right there is just is delta x, which means the change of x. And so this, remember, is opposite thinking. Because you would think that x minus h would move it to the left and plus would move it to the right, but again, it's opposite what we think. So then we're going to move on to our vertical transformations. Those would be after the horizontal. So first we're going to look at our a value, because that's multiplication division. So if a is less than 0, you're going to reflect the graph across the x-axis. If it's something that is in between 0 and 1 or bigger than 1, and of course that's the absolute value of that, we are going to stretch or compress the graph vertically by a factor of the absolute value of a. And then if k is bigger than 0, that goes up, and less than 0 is down. And these are our k values. So this right here would be the change in our y values. And of course, those make sense. So again, same thing. We always want to plot our x points first, and then we go to our y coordinates. So we've already looked at this general equation right here. Again, and so here are all the different transformations that we have talked about. And so we're going to look at each of these different variables, and that's going to help you determine what the graph is going to be doing. And so, of course, this is kind of like our key, it's our graphic organizer to tell us how to make the transformations to our parent graph. So again, horizontal transformations change the x values, and vertical transformations change the y values. So this would be a change in x, this is a change in x, and then a and k would be a change in the y. So when we're doing the order, we always want to do our b first, then we do our h, then we do a, and then k for the order that we follow. Oops, that would be the fourth thing that we do. Now, up here, I didn't really say too much about the difference between 1 and 2 and 4 and 5. Does it matter if you stretch or compress and then reflect across the y or x axis when you are doing these transformations? No, but again, I just like to follow the specific order. So you're going to always see me do the reflections, then stretching, compressing, and then moving left or right, and then reflection, stretch, compress, up or down. All right, so description of the transformation. So if we look here, we're seeing that we have our graph, and what are we doing to our graph? So notice that from f of x, we're doing f of b of x. Where is that b? The b is inside parentheses. So anytime it's inside our parentheses, as we talked about before, we know that's going to be a horizontal transformation. When it's on the outside, such as right here, this f of x, that is on the outside, so that's a vertical transformation. So try to pause the video and see if you can write out what each of these transformations are and whether or not it's a change in x and y. And then when you're finished, unpause, and we can go ahead and take a look at it. So for this first one, it is on the inside, so we know this one, and we're going to, because it's hard to tell, say that if you look at this one, this is in between 0 and 1. So we're going to say that this one's a horizontal compression, because remember, it's opposite thinking. So this is a horizontal compression by a factor of 1 over b. Remember, it's the absolute value of that. So what does that change? That changes the x values. So the next one is also in the inside. So this one is a horizontal stretch by a factor of 1 over 1 over b, which is just b. So same thing, we do 1 over b. Again, that changes your x. So sometimes you'll see, instead of me writing all the word horizontal compression out or horizontal stretch, you'll see me write HC, or you might see me write HS. It's just a lot easier to write than having to write horizontal compression or horizontal stretch each time. So for the next one, we have a negative, which is on the inside. So again, the negative on the inside is a reflection across the y-axis. And so you'll notice that this first part right here, these three, we're all looking at the b variable. And so this one, of course, changes our x as well. So looking at the next one, we have the negative on the outside. We have a and the 1 over a. Notice these are being multiplied. So that means we're looking at what our a value is doing. So we can look at, again, this organizer up here and to see what each variable does to the graph. So we know the negative on the outside is going to reflect across the x-axis. And then the a on the outside is a vertical stretch by a factor of the absolute value of a. And remember, the vertical movements are the ones that make sense. And then this one is a vertical compression. Oopsies. By a factor of the absolute value of a. And so these were all my a values. And a, of course, is going to change the y coordinate of your graph. Then we have f of x minus h and plus h. Notice these are the inside. So remember, inside is a horizontal movement. So the minus h, remember, moves it to the right h units. And the plus h moves it to the left h units. And just go back here real quick. Sometimes you might see me write VS for vertical stretch and VC for vertical compression. So the left and right, of course, change the x coordinate. And then we have the K, which moves it up or down. So plus K moves it up K units, and minus K moves it down K units. And of course, up and down change the Y coordinate of our graph. So before we get to actually graphing these, we want to be able to look at the equation and kind of know what each of the different transformations are to the parent graph. So the first thing we want to do is identify what the parent graph is, so the name of the function, and then we identify the b, h, a, and k. So if I look at this first equation, remember we looked at this chart before the other day, and so for this we have all of these different functions, linear, absolute value, etc. These are the parents graph equation, and then these are the different transformations that are being made. So each of the variables, you can see the b and the h are always on the inside of the parentheses or absolute values, etc. And the vertical movements, the a and the k, are always on the outside. So we're going to kind of use this chart to help us answer these questions. So looking at these first three examples, these are of course all trigonometric functions. So that is the name. And we want to write down then what the parent graph is. So in this case, this first one is the sine, the second one is the sine, and the third parent graph would be the cosine. So we'll go ahead and write that in. So now that we have that written in, we can go ahead and look at what each of the different variables is doing to our parent graph. So for the first one, we know the parent graph is y equals the sine of x, which is trigonometric, which is the name of the function. So from our graphic organizer that we talked about the other day, we can see here for the trigonometric, which is down at the bottom, each of the variables. So the a and the k on the outside, the b and the h would be on the inside of the sine. And so we're going to use that to kind of help us. So for this, we can see that the b would be, of course, right here, which is the 4. There is no h. So if there's no h and we're adding or subtracting something that is not there, remember that number would be 0. Then we look on the outside, we have an a value. So our a value here is 3. And then our k value is right here, which is 2. So then after I write that down, I could go back to my graphic organizer in the front and this equation. And of course, I would want to look at what does that b value do to my equation first. So if we go back here, we can see that the b value is a 4. So when I look at my graphic organizer at b, I know that b, is that less than 0? No. So does it reflection across the y-axis? No. B, the absolute value of it is bigger than 1, so that means it's a horizontal compression by a factor of 1 over B. And it's not in between 0 and 1, so it's not a horizontal stretch. So then if I go back to my equation right here, that's what I would write into my chart. So that I have, it is a horizontal compression by 1/4. The 0 for the H means that we are not moving our graph left or right. So in this case, we don't really need to write anything in this box, but that just means there are no transformations or none. So then the 3 is our A value, which is on the outside. So of course, then again, we could go back to our graphic organizer, look at the A value. Is A less than 0? No. So is it a reflection across the x-axis? No. The absolute value of A in this case is going to be bigger than 1, so that's a vertical stretch by the absolute value of A. So that's what we can go ahead and write in our table. So then the last variable we have is our k, which is on the outside. It's being added. So remember, when k is being added, you could go back and look at your graphic organizer if you like, but we know that this would be moving the graph up 2. So these would be all the transformations that we're making to our parent graph, the sine of x, in order to get this new transformed equation. So the next what you should do is go ahead and pause the video and see if you can do number 2 on your own, and then we'll go over it. So first thing you want to do is look at your variables. So if we go back to our general equation that we have right here, we can see that we have first our b is what we want to look at, which is on the inside of the parentheses. So that would be the 1/2. There is nothing else inside the sign, so that means there is no h, so that would be 0. On the outside of the sign being multiplied, that's always our a value. So in this case, our a value is -1. So remember the number is not there, it's 1. And the k, there is no k value, so of course that would be +0. So this would be 0. So then what does the 1/2 do to our graph? You could go back to your graphic organizer and you would see that the 1/2 is a horizontal stretch by a factor of 1 over b. So if we do 1 divided by 1/2, remember when you divide a fraction by a fraction, you multiply by the reciprocal. So this is really 1 times 2 over 1, which is equal to 2. So this is a horizontal stretch by a factor of 2. The 0 means that we are not moving our graph left or right, so none, or you could just leave it blank. The -1, so that is, of course, our a value. So if we go back to our graphic organizer and look at our a value here, a is less than 0, which means this is a reflection across the x-axis. Now remember, the absolute value of a is not bigger than 1, and the absolute value of that a value is not in between 0 and 1, so we're not vertically stretching our graph, nor are we vertically compressing. The only thing we're doing in this case is a reflection across the x-axis. And then the 0, of course, means that we are not moving our graph up or down. So none, or you can leave it blank. So again, I would go ahead and pause the video and see if you can do number 3 on your own, and then we'll look at it together. So now we're looking at the cosine graph. So the cosine transformations are similar to sine, so all we would do is take out the sine here and write cosine. So we can see that our b is here, this is our h, a would be here, and k would be here. So our b value is 3, our h is 2, our a is equal to 1 if it's not there, because remember, multiplying, what doesn't it change the equation is when you're multiplying by 1. Unlike the h and the k, when it's not there, you write 0 because you're adding and subtracting what doesn't change your equation, which is 0. And then, of course, our k value is 1. So what does that b do to our equation? So that b would be, of course, opposite thinking. So this is a horizontal compression by 1/3. The 2 is our h value, so again, opposite thinking. So the 2 is going to move our graph to the right 2. Then we have the next one, which is 1. So if I go to my graphic organizer for A, if I look at 1 is not less than 0, so we're not reflecting it. The absolute value of 1 is not bigger than 1, so it's not a vertical stretch, nor is it in between 0 and 1, because these are not equal signs here, so it's not a vertical compression. So if we're multiplying by 1, remember 1 times something doesn't change our equation, so that means that this actually is not doing anything to our graph when we're multiplying by 1. But adding or subtracting 1 does do something to our equation, so that k value would be moving our graph up 1. And so just to recall that b and the h, of course, we always do first. These are the changes in our x, our delta x, and these are the changes delta y in our equation. So if we were to graph this, we would do the x coordinate first, and then we're going to make the changes to the y, which we'll talk about later. So here are the next equations that we have. And again, you could always pause the video and try to see if you could do these on your own. So the first thing you want to do is be able to figure out what are the parent graphs. So for this first one, we see a square root symbol. So that means this, of course, would then be the square root function. Over here, we see that this has a square. So if this has a power of 2, then we know that is quadratic. And over here, the absolute value symbols give it away. So this is the absolute value equation. So go ahead and take a minute to write that in. So now that we have that written in, we can of course use this organizer here to look at the transformed equation. So notice that here the b and the h would be underneath the radical. The b and the h are inside the square because those are again the horizontal transformations. And here the b and the h are inside the absolute value bars. So of course see if you can pick out your a, b, h, and k, write them out, and then pause the video and we'll go through the answers. All right, so for this first one, our B is 1, H is 3, A is 4, and K is 8. So notice that there's nothing being multiplied underneath the radical here by the x minus 3. That is why our B value is 1, because 1 times anything doesn't change our equation. And so if our B value is 1, if we go back to our graphic organizer equation, we know that when B is 1, it's not less than 0, so there's no reflection. And also it's not greater than or equal to in the symbols here, so it's not a horizontal stretch or compression because again, 1 times anything does not change our equation. So that means that the B does not do anything in this case. H is 3 because it's underneath the radical and it's attached to the x, so that 3 means that we're moving to the right 3. A is equal to 4 because it's on the outside being multiplied, so that's a vertical stretch by 4, and the k is equal to 8, so we're moving it up 8. So for the next one, we have our B is 7, H is 1, A is negative 1/2, and K is 3. So that 7 is our B value, which is a horizontal compression by 1/7. The next one is H, which moves it right 1. The A has two things that we are doing. We have a negative and a 1/2. So if we go back to our graphic organizer here, notice it says the absolute value of A if it's, or excuse me, if the A value is less than 0, it's a reflection across the X. That's the first one. And notice that it also fits into our category 1/2. The absolute value of it is in between 0 and 1. So that means it's also a vertical compression by that value. So that's why for this one we have two different um, parts. So we have a reflection across the x-axis and a vertical compression by 1/2. So that would, if that was the same thing, if we had a b value, if our b value up here had a negative in front, so if b was equal to -4, we would have had a reflection as well. So this would have been a reflection if it was negative here across the y-axis and then horizontal compression by 1/4. But of course we didn't have one. So then for the last part, the k is just moving it up 3. For number 6, we have B is 1 because again, there's nothing being multiplied there. H is -1 because remember it's opposite thinking. So to get it to be plus here, we have to have a minus. A is 1/4 and K is -10. So that 1 times anything doesn't change it, and you can look at your graphic organizer to help, so that's none. This would move left 1. This is a vertical compression by 1/4 and down 10. So let's go ahead to the next page. So go ahead and see if you can do these three equations on your own. When you're finished, go ahead and unpause and we'll look at the answer. So just look at this first part. We know that this parent graph is y equals 1 over x. This is a rational function. And again, you can use your equation graphic organizer to get this equation here. Notice a is always in the numerator and k is on the outside. So our b value is always attached to x, which is underneath the division symbol. So that's here. Number 8, we have a cube root function, so y equals the cube root of x. Notice that a and k are on the outside of the cube root, b and h are underneath. The next one's absolute value function, so y equals the absolute value of x. Notice that a and k are on the outside and b and h are the inside attached to x. So if you haven't already written in the variables and written down the transformations, go ahead and do that, pause the video, and then unpause it and we'll look at the answer. So for the first one, we have 1, 8, -12, 17. 1 times anything doesn't change it, so that's no transformations for B. H is 8, which moves it to the right 8. A is -12, which has two different things because of the negative and the number. So this is a reflection across the x-axis and a vertical stretch by 12. And the last one is K, which is 17, which moves it up 17. For the next one, number 8, B is equal to 3. So that is going to be a horizontal compression by 1/3, because remember this is opposite thinking. H is 0 because there's nothing there, so that means there are no transformations, not moving left or right. A is 5, so vertical stretch by 5, and K is 0, so none. For the last one, absolute value, we have B is -1/8, which is a reflection across the y-axis and a horizontal stretch by 8. H is 1, which moves it right 1. There is no number on the outside being multiplied by this, so that a value is of course 1 because 1 times anything doesn't change it. So there means there are no transformation because it doesn't change the equation. And then of course there's nothing being added or subtracted on the outside, so k is 0, so that means none. All right, so let's go ahead to the last part of this, which is writing the equations given the transformations. So it says transform the given function f of x as described and write the resulting function as an equation in terms of g of x. So here we have f of x equals x cubed, which is of course the cubic function. So we have a horizontal stretch by a factor of 3, translate right 3, reflection across the x-axis, and translate up 1 unit. So first thing you want to do is identify your variables. So horizontal stretch, which means that's our b value. Remember, it's opposite thinking. So remember, it's always the absolute value of 1 over b. So that means b is equal to 1/3, because 1 divided by 1/3, the absolute value of that would be equal to 3. Translate 3 units to the right, which means h is equal to 3. Reflection across the x-axis, that's our a value. So in this case, to get the reflection, we need it to be negative, and I don't see any vertical stretching compressing, so this would just be -1. And translate up 1 unit, which is our h, so h is equal to 1. So if you need to look at that graphic organizer for the equation, you could. So remember that for our cubic function, we get y is equal to a, and then parentheses b, parentheses x minus h. All of that's being cubed because those are the horizontal transformations, and then plus k. So then you're just plugging these values into this equation. So in this case, we have g of x is equal to -1, parentheses, our b value is 1/3, times x minus h, which is translating right 3, so -3. All of that is being cubed, and then plus 1. So again, do you need to write the 1 there? No, but you could just write the negative if you wanted to. So negative, and then parentheses 1/3, parentheses x minus 3, all of that being cubed, plus 1. So the next one over here we have is our, of course, square root function. Reflection across the y-axis would be a negative. Translate to the left 3, so this would means that our b value needs to be -1. Translate left 3, so that would be an h value. Left means we need a -3. Vertical stretch by a factor of 2 and reflect across the x-axis, so both of these are a. So a has to be negative and vertical stretch by 2, so -2. And translate up 3, which means k is equal to 3. So our general equation for this is y is equal to a times the square root of b parentheses x minus h, and then plus k on the outside. So in this case, g of x is equal to -2 times the square root of -1 times x plus 3, and then plus 3. Now, do you need to write this in factored form? Yes, always keep it in factored form, because if you were to distribute that -1, that changes what the equation looks like. So always leave it in the factored form. So go ahead and pause the video now and see if you can do these last two on your own, and then we'll take a look at them together. So here, x squared is quadratic. And this last one, number 4, should have been absolute value. So for the first one, number 3, horizontal compression by a factor of 1/2 and reflection across the y, that's your b value. So we need it to be b is equal to -2, because remember, to get that 1/2, it would be 1 over 1/2, and the absolute value of that, which is equal to 2. Translating to the left 4 means h is equal to -4, because remember, it's opposite thinking. So for this one, we have our equation y is equal to a times b times x minus h, all of that being squared, plus k. That's our general equation. We just have to write in the variables. So in this case, we get parentheses -2, parentheses x plus 4, because it would be minus -4, which is plus, quantities squared. There is no a and there is no k, so that means a is 1, which we don't have to write, and k is 0, which we also don't have to write. So this would be our equation. Can you distribute that -2 to each of these values right here? Um, you could, but I would just go ahead and leave it in factored form always. So looking at the next one, we have absolute value function. So translate to the right to vertical compression by 1/2. So translating right would be h. So h is equal to 2 vertical compression and a reflection. So this is our a value, which is equal to -1/5. And translate down 5 units, which would be k is equal to -5. So the general equation for the absolute value, y equals a times the absolute value b times x minus h plus k. So in this case, we can go ahead and write our equation now. So -1/5 times the absolute value of x minus 2 and then minus 5. So now we have taken the transformations and written the equations. And so that'll be it for this right now. Let me know if you have any questions.